sketch the function f of x is equal to x squared minus 1 divided by x squared minus 4. First thing that we're going to be able to find is, let's find the vertical asymptotes. The vertical asymptotes are given in terms of x. So equate the denominator to 0, that is x squared minus 4 being equal to 0. This will give us x minus 2 and then x plus 2 giving us 0. And then we are going to find that x is equal to 2 or x is equal to negative 2. The horizontal asymptote, as long as the degree of the numerator is smaller than the degree of the denominator, the horizontal asymptote will always be at y is equal to 0. Now, another thing that I'm going to find here is I'm going to equate the numerator and the denominator to 0. If I equate the numerator to 0, I'm going to find x is equal to positive 1. Already the denominator, we equated it to 0, we found positive 2, and we also found negative 2. So I'm going to write a table of values to show all these. The smallest we have amongst these is negative 2, and then followed by a positive 1, and then we have got a positive 2. So we now put the factors that we equated to 0. We equated to 0 x minus 1. We also equated to 0 x minus 2. Also equated to 0 x plus 2. Right? So these are basically multiplying. These two are multiplying and then dividing. So I'm interested in the product. I can also say quotient because this is going to be dividing by this, but that is basically the same thing. When I equated x minus 1 to 0, I found positive 1. So as long as I put in this factor any value greater than positive 1, it's going to give me positive. For example, a 2. And then if I cross the 1, it will give me negative. For example, a 0. 0 minus 1 is negative. When I equated x minus 2 to 0, I found positive 2, meaning in the factor x minus 2, if I put anything above 2, it will be positive. Anything below, it will be negative. When I equated x plus 2 to 0, I found negative 2. Anything above negative 2 putting in this factor is going to be positive. For example, negative 1 is going to give me positive. And immediately I cross to give me negative. Now I'm interested in the product of signs. Negative, negative, negative is negative. This will be positive, this will be negative, this will be positive. And then now I'm able to put my number line here. Or let me say the Cartesian plane. So now on the Cartesian plane, the first thing that I want to put is the asymptotes which I found. We have got positive 2 and negative 2. Let's say positive 2 here and then negative 2 is here. And then we are going to also go to this one. Also, I put my asymptote there. We also have a vertical asymptote which is along the x-axis there. Right. Now I'm going to go to the table of values which I've written down. Remember, there is also another factor which I've included. When I equated the numerator to 0, I found a positive 1, and positive 1 is going to be somewhere here. So what this is telling us is for values of x smaller than negative 2, the function is supposed to be negative, meaning below the x-axis. We always follow the asymptotes. We are going to be following the asymptotes in this direction, also be following the asymptote in this direction. Simply connect these. And then from negative 2 to positive 1, the function is supposed to be positive. We are getting the product from negative 2 to positive 1, supposed to be positive, that is above the x, meaning that I'm supposed to move from here. Okay, supposed to be above. We always follow the asymptote, we can't cross it, so it will be going like that. And then from 1 up to 2, the function is supposed to be negative, meaning that is below the x-axis. So simply follow it like this, it will be able to go down. And then from 2 to infinity, the function is supposed to be positive, so it is above here. So this is going to be the graph of this function. Now we also need to find this value where the function is cutting the y-axis, and that happens when x is 0. If I put 0 here and 0 here, that will just give me 1 over 4. So this is 1 over 4 comma 0. So what will be the domain of this function? The domain, the simplest value of x we can have, or the smallest, is negative infinity, and then we are cutting at negative 2. We are not including those. And then from negative 2, I'm going all the way up to positive 2. And then from positive 2, I'm going to infinity. And then the range of this function The smallest I'm having y value is negative infinity. I'm going all the way up to positive infinity. So that is it for this one.